Johnson. I'm working as part of Project 3.3 as a PhD student at Adelaide University. I'm originally from Adelaide. I did my undergraduate degree at Adelaide University in Arts and Science, and then I moved on to honours in Geology in Science, and then from there a PhD. I'm doing my PhD in geology, in particular in the geochemistry of landscapes. I find that really interesting and also a little bit challenging, which is why I enjoy it so much. Looking at the chemistry of a landscape is quite challenging because there are a lot more unknown factors rather than just looking at an outcrop of rock. It's very hard to pinpoint where certain elements are from, but that's part of the fun as well. My PhD project is in the Eucla Basin, so that's in South Australia and also in Western Australia. I'm looking at heavy mineral sands, the whole mineral system of how those sands got there for Iluka Resources. They have a mine there called Jacinth, and I'm looking at how those heavy mineral sands got there, the processes that transported them and how they've been preserved over time. My project will hopefully help Iluka Resources better understand the mineral system that they have their ore deposit in, which may help them in the long term with another resource or also better managing the resource they have. I'm doing my project under the supervision of Steve Hill at Adelaide University. What's fantastic about working in a group of 9 PhD students in approximately 6 different locations is that we can bring a quite diverse range of information back into a group where we can analyse it as a team. What we're looking at producing is a guide for the industry so that they actually have information of what they can sample where, how that is chemically different and how they can use that for mineral exploration. What I really enjoy about working at the CRC is that it has a really innovative environment where any ideas that you do come up with will often be taken through to their endpoint. The most exciting development of my research has been actually able to characterise differences in carbonates. So when you're sampling a carbonate, in particular in southern Australia, looking at a difference between a pedogenic carbonate, which you might be able to use to give you a signature of underlying bedrock, and also a carbonate that's been derived from a limestone, which you wouldn't be able to use. This is really important because you can't distinguish those two always in the field. I find the chemistry of a landscape really, really interesting, and trying to actually understand that over millions of years is quite hard, and I love that challenge.